Hi everyone, I am Manya and I am currently pursuing my BTech from Gokraj Rangaraju Institute of Engineering and Technology under the Department of Information Technology, and I am here to present my mini project on the topic Air Canvas using computer vision along with my teammates Sabha and Madhuri. Before I continue, I would like to show my thanks to N. Monica ma'am, Assistant Professor in GRIT, whose guidance led us to the completion of this project. The title of our project is Air Canvas, which aims on providing an interesting virtual way of learning and interacting. This abstract introduces Air Canvas, which transforms the physical space into a digital canvas where users can paint and draw simply by moving their hands or any other objects in the air. With the occurrence of unexpected pandemics, there has been a need for virtual reading and learning. Our project is a medium through which that need can be fulfilled in an interesting and exploring manner. This project uses the concept of computer vision, which is a branch of artificial intelligence that uses various processing techniques, machine learning, and deep learning methods to replicate and automate tasks that require human visual perception. This includes object detection, recognition, tracking, scene understanding, image segmentation, and more. This includes the use of various algorithms such as convolutional neural networks, which are commonly used for detecting and localizing objects within images, including hands or specific objects in the camera's field of view. These algorithms can be implemented using various machine learning libraries and frameworks in Python, such as OpenCV. By integrating these algorithms into the Air Canvas project, the application can offer a more immersive and intuitive painting experience for users, enhancing creativity, learning, and interaction. An existing system similar to this project is the Google Jamboard application, which is a paid version of a virtual collaboration by Google. As a member of the G Suite software family, Google created Google Jamboard, an interactive digital whiteboard. It is intended to support group ideation, group presentation, and group instruction. Jamboard is a digital interactive whiteboard developed by Google to work with Google Workspace, formerly known as G Suite. It was officially announced on 25 October 2016. It has a 55-inch 4K touchscreen display and can be used for online collaboration using Google Workspace. The display can also be mounted onto a wall or configured into a stand. Google Jamboard is a paid application that requires user verification and login, along with the required fee to set up and fully use this application and utilize its functionality. Due to these reasons, Google announced on September 28, 2023 that Jamboard was shut down on December 31st, 2024. Our proposed system is an open source application that can be used free of cost and doesn't require complicated steps or digital equipments for its working and functioning. Although Google Jamboard is an effective tool for teamwork, there are a number of special benefits to Air Canvas projects, especially when it comes to its creative approach to painting and interaction, which includes free hands interaction, open source environment, compatibility, and portability. Now I'm going to explain the various algorithm and technologies that we used in this project. The MediaPipe library consists of hand models which uses deep learning algorithms such as convolutional neural networks for hand landmark detection. The CNN model helps in feature extraction and classification with the help of the pre-trained datasets available in the module. The open source computer vision library, commonly known as OpenCV, is used for video capturing and image processing. It uses various internally built machine learning and image processing algorithms. Coming to the system architecture, the first step is to install and enable all the required libraries and frameworks. We use the help of command line interface for this. We managed all the installation work and ensured that the workplace is properly configured. Then we install the integrated development environment where the code will be executed. We have worked this code on PyCharm, VS Code, and Jupyter Notebook since all of those support the Python development environment. Once the IDE is launched, we run the code. The code will then import the required libraries as specified. We have imported the main libraries like OpenCV, MediaPipe, and NumPy. The imported libraries will then load the predefined and pre-trained dataset present in the MP hand tracking mechanism module of machine learning. Use MediaPipe library to access the pre-trained dataset for hand tracking. This dataset helps in detecting and analyzing hand movements accurately. Then we enabled additional functionalities such as hand tracking mechanisms, NumPy functionalities, and array functions which are required for code execution and tracking. We have ensured that these functionalities are integrated into the main code for the seamless execution. This code will activate the webcam from the device, which will state the detecting hand movements. OpenCV is used for this functionality. It will begin capturing video frames for real-time handwork detection. The hand tracking module from MediaPipe Solutions will detect the hand movements. These movements will be sent to train dataset for verification and functionings. The MediaPipe module is used for this task, which compares the landmarks with the trained dataset for accurate hand tracking and verification. A user interface will be enabled for interaction. The system will store the relevant data points tracked for recognition and detecting points from the trained dataset. The main utilized module in these tasks are mp.solutions.hand and mp.solutions.drawing_utils. These modules are responsible for hand tracking and drawing landmarks. The system will continue running, tracking the hand movement until the user exits by pressing a predefined key. The next thing is the use case diagram. This use case diagram provides a high-level overview of the interactions and functionalities of the Air Canvas system from the user's perspective, focusing on the core task involving creating and managing digital artwork through hand gestures. As we can see in the diagram, we have a software application which initializes the variable and then reads the frame, detects the contours, starts drawing, tracking coordinates and executes the output. For initializing variables, we have used cv2.numpy, which is a library in Python. And for reading the frame, we have used our own webcam, which is present in our system. The next step is the class diagram. This class diagram shows how several components interact within the Air Canvas application. Air Canvas is the main controller, managing the canvas, colors, and user interactions via gesture recognition. Canvas performs drawing operations and layers, whereas Color Padlet maintains the available colors for drawing. Together, these modules attempt to create a full setup for creating digital artwork with the motion of hand. The next step is the activity diagram. This activity diagram provides a visual representation of how users can interact with the Air Canvas system. It also shows how different components collaborate to facilitate drawing based on hand gestures and user input. The main thing in the activity diagram is that once we capture the video from the webcam, we process one frame at a time. Each frame detects the hand region and then draws an RP. The RP is divided into two regions. One region selects whether we have chosen a color or eraser or any other functionality, and the second region will enable the drawing functionality. If the given desired line is greater than 1.2, then we add the coordinates to DQ. If nothing is required, then we simply draw or erase by choosing region A elements. The next step is the sequence diagram. This sequence diagram provides a clear overview of how the Air Canvas application operates. From user interaction to internal processing, it involves image capture, hand tracking, gesture recognition, and canvas drawing. Coming up to the code implementation, we have implemented this code on Jupyter Notebook, where the first step involves importing necessary libraries. We have imported the main libraries as mentioned, which are cv2, numpy, mediapipe, and collections. Then we initialize and dequeues to store different points for different colors. We have also mentioned the various indexes and kernels which are used for image dilation, and also mentioned the various color formats that we will be using in our project. We have set up the canvas window with color buttons, added text layer to the canvas windows, initialized the MediaPipe for hand tracking, as well as the webcam. Once we implement the code, the moment I put my hand in front of the camera, it will automatically detect the landmarks in my hand. As you can see, it is continuously detecting my index finger. Once I move my hand in region A, it will stop detecting and clear the frame. It automatically detects the color and draws the image. I can change the color of the image by simply moving my index finger from one range to another range. Again, if I move my hand to the cleared button, it will clear all the lines automatically. I would now like to conclude this project. Thank you.